Good morning, everyone. Welcome to Las Vegas. I'm Micah Hausler. I'm a principal engineer on the Amazon EKS team.
And I'm George John. I'm a product manager in the Amazon EKS service team. Thank you all for being here with us today.
And so you're in the CON335, securing Kubernetes workloads in Amazon EKS. So we're here talking today about security. And one of the oldest forms of security you can think of is probably a doorway, a door, right? Sometimes you want to keep things out or you want to keep things in. And so we're going to use this theme of entry control throughout our talk today to kind of frame our discussion about security. So to talk about our agenda a little bit, it's going to be kind of three high-level pieces. We're going to be talking about securing access into the Kubernetes cluster, securing access from the cluster, and then securing access within the cluster. So these are going to be the main points of our discussion. And to give you if you're not familiar with Kubernetes, quick show of hands. Who here uses Kubernetes or has used Kubernetes or EKS? Okay, so pretty much everybody. Great, awesome. If you're not familiar with Kubernetes, really brief overview. Kubernetes is a container orchestrator. So it controls and schedules containers on compute. In EKS, that's EC2 instances, Fargate, AWS Fargate, and you can use those, run those applications. That can be your first-party applications, that can be vendor applications, all kinds of things. And those often interact with other AWS services like S3 or relational database, RDS, or Amazon Bedrock or anything else, right? So that's kind of just for a high-level view of what is Kubernetes and how does it work. So we're going to jump over into the first section here.
All right. Imagine yourself, you're living in prehistoric Greece, right, in 1250 BC, and you're tasked with securing the Acropolis, right, which is the most important part of the city. What would you do? You might build something like this. So this is a picture of Lion's Gate in Mycenae, Greece. If you look at it, it's a huge wall fortified with giant stones with a door that can be shut. For that time, it was pretty cutting edge. In fact, like 1,000 years later, when the Greeks saw this, they thought it was built by giants. So from a very early time, we know that securing the front gate is very important. Fast forward 2,000 or 3,300 years, it's 2018 AD, and Amazon EKS was just launched. And as you can imagine, securing the front gate to EKS cluster was equally important. So the approach we took at that time was to a very Kubernetes native open source kind of a method to create or secure your clusters. So that meant that you can use Kubernetes permissions along with IAM to define a mapping through a config map to say who can access what. Now this approach had a couple of trade-offs, right? On one hand, it meant that you can use IAM. You don't have to create another identity provider. You can use IAM along with Kubernetes RBAC to set up access, which meant that you also get all the goodness of IAM, right? Or auditability with CloudTrail, multi-factor authentication, and things like that. So those are all the good things. On the other hand, we've been getting customer feedback on some of the experience challenges with this approach. So one thing we have heard is the fact that customers have to use multiple APIs to bootstrap a cluster with access. So by that I mean you first use EKS management APIs to create the cluster. You've got to wait for the cluster to be ready. And then you use Kubernetes APIs to then define the mapping in the config map between IAM principal and the Kubernetes permissions. So that's one feedback we've got. So what's a downside of that, right? So that means that you can really use automation like infrastructure as code tools to bootstrap a cluster with the access you need in a single step. Another feedback we've been getting from customers around the whole experience being a little bit finicky. You got to really make sure that you don't make any typos. All the mappings are exactly the way it's supposed to be. And if you do make a typo or a mistake, you might get locked out. I mean, there are ways to restore access, but still that's not an ideal experience. And finally, when you create a cluster, the IAM principle that creates a cluster is automatically granted super user privileges on the Kubernetes permissions, which again, if you, for whatever reason, delete that IAM principle, you kind of get locked out. I mean, you still can get access, but it's not the ideal experience. Now, if you don't believe me, just look at so EKS, if you don't know, we have a public roadmap on GitHub. A lot of customers have given enough feedback that this experience is not ideal. But we have some good news for you. We have an upcoming feature from EKS called access management that's going to address most, if not all, of the issues. Let me hand over the mic to Micah to talk about the APIs, how we build it, and just to give a quick demo.
Thanks. So we're really excited about this cluster management access. It's coming very soon. Some of the key highlights here are that it's going to provide AWS APIs. So as George talked about, you have this config map in the Kubernetes API. When you create a cluster, you've got to go to the AWS EKS API, use AWS credentials to talk to that. Then you've got to switch to a completely different API to edit a file, basically, in the Kubernetes API. So with this new feature, it's going to be AWS native APIs. So it'll work great with infrastructure as code tools. This also really simplifies the access. As a cluster is created, you can add entries even before the cluster is finished creating. So you don't have to wait for the cluster to create to start bootstrapping permissions into the cluster. And then it also provides granular control. So rather than, again, having to give someone cluster creator permissions and then expect that identity to go and edit the permissions in the cluster, these are all secured with EKS APIs. There's permissions around them. You can do all your IAM policy around who can edit the access to the cluster. And here's just a brief screenshot of what this looks like in the management console. So when you create a cluster, you'll be able to configure what is the cluster access. Do I want the cluster creator to have any permissions? Maybe I don't. If I have some automation that's doing that, maybe I don't actually need that automation with my infrastructure as code or whatever it is to have access to the cluster. And then as you create, after you create the cluster, if you want to add additional entries to this management API, you can add those here. This is kind of another view of what this looks like. And additionally, we're going to provide coarse-grained policy access. So I'll show this in the demo in a second, but basically you can bootstrap some level of permission for these identities who can access the cluster. There's authentication and there's authorization. So the first half is that authentication part. Who can authenticate to the cluster? And then the second half is the sort of authorization part to say what level of access in the cluster do they have. And what this API ends up looking like, if you're familiar at all with the AWS CLI, you'll create the cluster and you'll set the authentication mode. And I'll show that in the demo in a second, what that looks like. And then you'll be able to create what we call access entries, and then associate those with policies. And then at post creation, you can always update that. So we'll go into the demo really quick, and I'll show you what that looks like. So here I have a cluster I've created. It's already been created, and I'm going to run through kind of what this API is going to look and feel like. So I'm just setting up some configuration here to use a specific config file. So I'm going to describe my cluster. And one of the first things you'll notice is when you describe a cluster, you see a bunch of settings around the cluster. The endpoint you're probably familiar with. We're adding a new field for authentication mode. And so this cluster has the API and config map already set. And so if you're familiar, again, with the existing method, if you look at the config map in a cluster, you can see the roles in the config map that are defined. So in this case, I've used a managed node group. I've already attached that. And managed node group, when you use the EKS API for that, it automatically adds this entry into the AWS Auth config map. So that's basically, you can think about it as an empty config map, but with the EKS generated one. Then, as shown previously, you can update the cluster config, and we have 3 different modes. If you have an existing cluster or create a new cluster, the default mode is going to be config map. So it's going to look and feel the same. So any controls you have around who has access to the cluster, and if I'm managing access to the cluster, that's staying the same. There's not going to be a new, there is this new method, but by default, it's not going to be enabled. You'll have to enable it. The second mode is this API and config map mode, which means we look at the entries in the API, the EKS API that you manage, and then as well as the config map, so kind of this migration phase. And then the last mode is just API only. So we're only using the new EKS APIs to configure access to the cluster. So I've already updated this cluster, so this call is going to fail, but you'll see API and config map setting that to the cluster. So now I'm going to list access entries. And I have 2 in this cluster. So what happens is I created this cluster, but personally I haven't created any access entries. Because I updated the cluster to API and config map, EKS automatically added the cluster creator for me and added the node role for my nodes to the API. And so I can describe these. I can look at like the admin, the cluster creator role, and it's just showing there's my principal identity and the ARN, and then I can do the same to just describe the node role. The one key difference here is on that type, you'll see EC2 Linux. That just, we do some additional configuration management of the permissions because a node, different nodes have different permission levels in EKS. Like the Windows nodes have a slightly different set of permissions than like the EC2 Linux nodes. So that's the type you see there. But for most human users or not even human users, but other machine users, it'll just be a standard type. And then you can finally, so just wanted to illustrate here, if I try to roll back my cluster to config map only, it's actually going to fail. We don't support rolling back to the config map because we need those entries in the API. And I'll just show you briefly. This is an AWS config file I'm using just for this demo. And this shows, OK, I've got a couple different profiles. And this just lets me sort of illustrate different roles accessing the cluster and having different levels of permission. So I've got a base role. That's the role that I use to create the cluster. So right now, it's administrator in the cluster. And I've got an additional role that I'm calling like cluster admin, and then like one that's called cluster viewer. So if I want to create a new access entry, you just call the API. Again, you can do this with infrastructure as code and anything else is when this comes out. And so now I've created this access entry for this viewer. Right now, it doesn't have any permissions in the cluster. So if I want to describe from Kubernetes, what are the built-in cluster roles? So these are the cluster level permissions in Kubernetes role-based access control, or RBAC. And I'm going to grep out all the system roles that are used by service accounts. So there's really just 4. So there's admin, it's kind of a lower level admin. There's full cluster admin, and there's an editor role and a viewer role. So we create in this new API access policies in the EKS API that are roughly analogous to those 4 Kubernetes roles. Again, as I called out, these are coarse-grained policies that just give you sort of bootstrap ability to let someone have view access to the cluster, or something have view access to the cluster, or administrator access to the cluster. And you don't have to use those at all if you want to use RBAC, or you can use those with RBAC. So here's just a list of the policies that we're going to have at launch, which, again, pretty familiar. Like you see the admin policy, again, similar to the RBAC policy. But you see some additional ones here, like nodes and EMR. So we're going to be using this new API also not just for humans or for other automation that needs to access the cluster, but other AWS services that need to access your cluster will use this method. So when you describe access to a cluster, you'll see, oh, OK, if I'm using EMR with EKS, it's using this role in this policy. And so now I can associate an access policy. I'm going to associate that viewer role that I have with the EKS view policy. And so now if I switch my AWS profile to use the viewer IAM role, I can do get caller identity that just says, who am I? What is my role? OK, now I'm actually the viewer role. I'm not the cluster creator. And OK, if I use that, can I try to get all pods and all namespaces? OK, great, I can. Awesome. I'm not the cluster administrator, but now I can access the cluster. But if I want to try to do any mutation, that's not in the viewer role policy. So if I try to create a config map and just use the Kubernetes command line from literal, just setting a key and a value on a config map, that's actually going to fail. This user doesn't have permissions to create config maps. And then if I go back to the admin role that I created the cluster with, I'm just calling it the base profile. I can update the cluster config to API. So that's in progress. And I can get back caller identity, and I can still get my pods. So that resumes. That's the demo. And so how does this work under the hood? So if you're familiar at all with EKS, we use an open source project called AWS IAM Authenticator. It's on GitHub. I'm a contributor to it. We have other folks at AWS who help maintain it as well. What happens is that the client of Kubernetes makes a call to Kubernetes. And when they do this, they send a token, a bearer token. That token gets interpreted by Kubernetes and says, okay, I don't know how to handle this token, but I know I have the IAM Authenticator authentication webhook enabled. That's managed by EKS. And what that does is it knows how to take that token. So what I say is a token, it's actually a pre-signed SIGV4 request for the getCallerIdentity API that I showed earlier. So as a client, when you call getCallerIdentity, the response you get back from AWS is who you are. If you pre-sign that URL, like if you're familiar with pre-signed URLs with S3, you can give someone an S3 pre-signed URL and they can get an object for some period of time as that signature is valid, but without having to give your credentials to someone else, right? So this works the same way. You can pre-sign a URL for getCallerIdentity, give it to someone, they can execute that call, but only that call, and see who you are. So that's how this works. So IAM Authenticator executes that request against the Secure Token Service, or STS, and gets back a response to see who is the client. And then returns that to the Kubernetes API to say, here's who the user is. And with the config map mode, with the existing way that we've worked, the IAM Authenticator process looks up that auth config map to say, okay, I see this rollback from STS. What permission, if any, does that have in the cluster? And then tells Kubernetes, this is who the user is. So the key difference here is, as we introduce the API and the mode and API config map, the EKS API now is a source of truth for this too, right? And so we push down to the Kubernetes control plane that we manage, those records that you send, and onto a file on disk. And now Authenticator can merge that context and to actually take precedence with the EKS APIs over whatever's in the config map when you have API and config map mode, and then send that back to the API server to say, here's who the client is. And then when it's API mode only, it just obviously ignores the config map and only reads from the file synced down through the API on disk.
All right, so far we looked at how you can secure access into the cluster or the front gate of the cluster. So next section, we are going to look at how you can secure access from within the cluster to resource outside. So this is a picture of Fort Jefferson, 68 miles off the coast of Key West in Florida. Just a little bit of, let me ask you, so if you are given the task to build a facility that secures egress, or you want to make sure people doesn't leave the facility, a good place to build it would be an island surrounded by water. So this facility, just a little bit of history here. Dr. Samuel Mudd, who kind of helped the assassin of US President Lincoln, was imprisoned here for a period of time. When this facility used to be a federal prison, I think in the mid-19th century. So coming back to EKS, how do you make sure that you're able to secure or control what resources your applications are accessing from within the cluster to the outside? So we have this feature called IAM roles for service account. It's also known as IRSA. We have had it for a couple of years now. So prior to IRSA, the way you would give your pods running on EC2 worker nodes permissions to access, or IAM permissions to access other AWS resources, was through by leveraging the IAM role attached to the EC2 instance itself. So this meant that all the pods running on the same EC2 instance will get all the permissions that the IAM role had, which might be overly permissive, right, and violating the least privilege principle. So in 2019, we launched IRSA. IRSA enabled you to give granular IAM permissions to pods. So you could have multiple pods belonging to multiple applications, all running on the same EC2 instance, but still have different set of permissions. And IRSA has been great, and we have a lot of customers using it. One of the key things I want to call out is that when we build IRSA, we build it for Kubernetes on AWS and not just EKS on AWS. Let me explain what I mean by that. So Kubernetes, today you have multiple ways you can run Kubernetes on AWS. Now you have EKS, which is a managed service. We have EKS Anywhere. You can run EKS on premises. You could also run your own Kubernetes clusters on EC2 instances, self-managed Kubernetes clusters. So in that case, you are responsible for both the control plane and data plane. We have a lot of customers using it. So we wanted IRSA to work across all these environments. So we did not, when we designed IRSA, intentionally, we did not take any dependency on EKS APIs. The way we built it was by leveraging fundamental AWS service like IAM. So when you set up, if you're familiar with IRSA, actually, quick show of hands, how many of you are using IRSA today? OK, maybe I would say 60%. So for the remaining of you, when you use IRSA, you kind of leverage some of the core IAM constructs like the OIDC provider. You create an OIDC provider in IAM. You use a role trust policy to then trust the OIDC provider you just created. So there are steps you go through. And the fact that we are not, you're kind of not interacting with any EKS API meant that you can use IRSA in EKS, in self-managed clusters, and other environments. But the feedback we have been getting from customers has been that there are some user experience challenges with that. There are customers, for instance, in regulated industries who have told us that the cluster administrator doesn't always have permissions to IAM, to administrate IAM. So for those customers, when they are setting up IAM roles to be used in IRSA, they have to reach out to the IAM administration team. So it means that there's a lot of back and forth between the cluster administrator and the IAM administrator. It makes the whole process manual, lengthy, not very automation friendly. So that's the feedback we've got. The second one is on the scoping of IAM roles. So the roles you use in IRSA today, if you're familiar with it, the trust policy, you're pointing it to the OIDC provider that's running on the cluster itself. So if you want to use a role, say, tomorrow on a new cluster, maybe as part of blue-green, right? You brought up a new cluster, you want to use the same role. You have to now go back to the roles trust policy and update the entry to point to the new cluster. And now if the roles are managed by a different team, now it's the administrator or somebody reaching out to the different team to kind of get this done. This, again, is, from an experience standpoint, not ideal. The third one is, like as you scale the number of clusters you have in your account, you might run into some of the limits, like the number of OIDC providers you can create an account, the size of the trust policy. Now, there are workarounds. I mean, you can get some of these limits increased, or you can duplicate the roles. But again, not the great experience. And finally, we have heard from customers, especially customers who have a very dynamic environment, who have ephemeral clusters that come up and go down. They want to bootstrap the cluster with all the add-ons, with all the permissions in a single step. IRSA today has a kind of a dependency that the cluster has to be in a ready state. If you create the cluster, you've got to wait for several minutes. The cluster has to be in ready state before you can use, which, again, is not great. So we have some great news for you. If you are familiar or if you're closely following some of the reInvent announcements, we announced a feature last Sunday called EKS Pod Identity. Before I hand the stage to Micah, let me emphasize that we have a lot of customers using IRSA. They are happy with it. They are using it successfully. We will continue investing and supporting IRSA. And at AWS, we take customer feedback seriously. And we have heard from a segment of customers who want a different solution. So we want to give you choices, right? IRSA would continue to exist. EKS Pod Identity is another option for you. Based on your use case and requirements, you can decide what works better for you. So with that, let me hand it over to Micah.
Thanks, George. Yeah, so I'm really excited about this launch. Some of the key points here are just that it really simplifies the trust. As George talked about, updating the role trust policy is a very permissive, how to say this? It requires a lot of permissions. In order to update a role trust policy, you basically have to be admin. You're able to extend the trust to basically anyone at that point for that role. So this makes it much simpler. You can say, I trust EKS to distribute this role correctly. It's also backward compatible. So it works side by side with IAM roles for service accounts. If you're using IRSA at this point, you can turn on pod identity. It will basically take precedence over IRSA. And then you can turn off IRSA. One of my favorite features about this is the scalable AWS. So if you're not familiar with attribute-based access control, basically this uses attributes from the identity to enforce permissions. So the way that we have done this is we added support for IAM role session tags. And I'll get into this in the demo and kind of how powerful this is. But that's a really exciting security feature here. And additionally, it's auditable like everything else. So all the APIs, the new APIs by EKS that support this, as well as the use by the pods, the AWS API used by pods, is all integrated with AWS CloudTrail. So here's just a brief screenshot of what this looks like in the AWS console. You'll go to, on a cluster level, create a pod identity configuration. And so this is just a mapping of an IAM role to a Kubernetes namespace and a service account within that namespace. So this is that mapping: cluster, role, namespace, service account. And then you'll be able to see a list of those associations in the AWS console as well. To kind of give you an overview of how this works. So say you have an IAM administrator who creates a role. We're going to call this role secret reader. They can set the trust policy on this role to allow on the effect, and then on the principal side, they'll set it to pos.eks.amazonaws.com, and the action is assume role and tag session. If you're familiar at all with using any identity in any compute at AWS, whether that's EC2 or ECS or Lambda or Code Builder, anything, this is basically how you do it, right? You trust the service. So that's one of the key features here, is that this will look and feel a lot like basically any other AWS service that you want to provide identity to. And so in this secret reader role, in order to use that role, you might have a cluster administrator, and you might give them permission to say, okay, I can create these these pod identity associations, but in order to do that, that's not it. I can't just give my cluster administrator create pod identity association. I also have to give them IAM pass role. Pass role is a key defense mechanism built into IAM that prevents privilege escalation. Just because the secret reader role trusts EKS doesn't mean your cluster administrator is allowed to use that role. They also have to have pass role on that role. So that's one of the key protections in this new API, is enforcing that check. And what that session tagging ends up looking like, and the way you can use that, and this is an incomplete example, but just to show kind of how this works, is say you have an AWS resource that's a secret manager secret, right? And those secret manager secrets have tags. Say the tag is EKS-cluster-name, and the value is whatever your cluster's name is. Same for Kate's-namespace and Kate's-service-account. The way that IAM role session tags come into play here is you can reference session tags in IAM policy. So in this example policy, in the condition, I've said the string must equal for the resource tag, so the resource on the secret must match the value of the same session tag in that session. So if I have an IAM role that I want to use in a cluster, that all those tags on the resource must match the session tags. So the great thing about this is I can reuse this IAM policy and even IAM role across multiple clusters and not have to write an individual policy per cluster or an individual role per cluster that hard codes the cluster name in the policy. I can just rely on the session tags and the resource tags to match. So what that ends up looking like is you have a container, say we have a yellow cluster, and it assumes the same IAM role, the secret reader role. The role session tag that EKS sets when it gives the credentials to the container in your pod is going to be EKS cluster name yellow. And the resource tag on a secret, whether it's whatever permission you give the pod, whether it's a create secret or accessing a secret value, must match the tag on the session tag. And the same for if you have a blue cluster, it's the same thing. But you can reuse the same IAM role and the same IAM policy. This is really powerful if you want to enable role reuse. If you have dozens of clusters and you're maintaining all these different roles that are essentially the same except for the hard-coded cluster name, you can do away with that and just get one. So this is just a brief overview of what those APIs look like. So through the AWS CLI again. So you can create pod identity associations where you specify, again, at the cluster level. So you have a cluster name, the namespace, the service account, and the role ARN. And then later you can update that as well to a different role. When you do update to a different role, you'll have to restart your pod because the pod will keep running with the previous credential from the previous session. And then you can list in one place all your pod identity associations and even remove them. So with that, we'll jump into a brief demo. So here I've got a couple clusters. I'm using kubectl, so I'm looking at the context that I have. I've got really I'm just going to be using a bluefish and redfish clusters. So the first thing I'm going to do is show you how I'm going to set up the roles. So I'm going to run through this. So I've got a role that I'm going to want to grant to my cluster. And I'm going to look at the policy document. So this is the policy document. We saw this already. It shows pods.eks.amazonaws.com. That's what it's trusting. It allows EKS to tag sessions and assume the role. I added an additional condition here to say I don't want this role to be used with just any cluster. I only want it for these 2 clusters. You saw I had a bunch of other clusters. I can add condition keys to say it's only allowed for these clusters. So if I don't want it to be just any cluster in my account, it can be specific ones. So okay, let's look at the policies on this role. So I've got 2 policies, an S3 policy and a secret manager policy. If we look at the S3 policy, it's got a policy so on the first stanza here, I've got 3 actions: delete, put, get, and get objects. But I have different resources that those can do. So I've got an S3 bucket, and it's a little bit long of a bucket name, but you can see on the first line, I've got a config prefix. After that, I've put in the session tag as a template variable here. So it must be config/cluster name /namespace name /service account name, and then it can do anything it wants under that. In the second line, I just have /data, and then after that, cluster name, and then everything. So that's kind of a common sort of a pool of a prefix for anything in the cluster can put, get, delete objects in that prefix. And then finally, I have a logs prefix, and I put the Kubernetes pod UID. So that's going to be a UID4. It's going to look at and be different for every pod. Why might you want this? Well, say you run a CI system, right? And you don't want, even at the service account name or even the pod name, because pod names can be duplicated over time, but UUIDs won't be. You might want every pod to upload to a different prefix but not be able to override others. That's an example where you might want this. And then finally, the role can list the whole bucket and can list my other buckets. So, all right, so if we look at the secret manager policy, this is going to be more tag-based rather than like S3 path prefixed. So I'm going to allow secret manager star, so any secret manager call, as long as the resource tag, EKS cluster name, so the tag on the resource is cluster name, key, and the value of that tag matches the session tag value for EKS cluster name. So I'm doing a cluster level tag here. And then I'm letting it do anything on all resources. It can get random passwords, so it can generate random passwords, that's fine. I can list all the secrets. I can't necessarily access them, but I can list them. And then a few other permissions for untagging. I deny untagging. I don't want to let it untag things, so you can't untag someone else's resource and then tag it as yours and claim it. And I don't let it manage any secret manager policy APIs. And so I'm going to go ahead and list my clusters. I've got bluefish and redfish. And I'm going to create a new add-on. So part of this new feature is that we have an add-on that does a credential exchange for the pod. So when a pod, and I'll get into this in a little bit, but when a pod starts up, it will reach out to this agent to get credentials. The agent will reach out to EKS to do the credential exchange. So I'm installing the pod identity agent. That'll take just a second here. And I'm going to list pod identity associations on my redfish cluster. None yet. Great. Now we're going to go ahead and create one. So we've got our IAM role. We've seen the policy. So we're going to go ahead and create that. And there it's created. So on the cluster redfish, and that pod role is the pod role. And okay, so now we've got a role associated with the cluster. What I'm going to do is I'm going to install a Kubernetes pod. So if I kubectl get pods, I don't have any pods. I have a deployment here. And this deployment, I'm going to do 2 things. So I have a service account. That's the service account that I referenced in my pod identity association. And it's actually a really simple container. I'm running Amazon Linux 2023. And I've injected a few environment variables. I put the bucket name, so that mapping that through a config map. And I've given the pod some hints as to its metadata. When you have session tags in a session role credential, you don't know that you necessarily have them. So I have to sort of inform the pod of, here's your cluster name, here's your pod namespace, your service account name, and the pod name in this case is the host name, so I don't inject that here, but I could do that as well. And same for pod UID. So those are injected as environment variables, and I've mounted some files as, or some config maps as paths in the pod, which we'll see in a second. So run sh demo setup. Actually, I can just run demo setup. So I'm creating some config maps that have some setup scripts in here, and I'm applying my deployment file into my Kubernetes deployment into the cluster. So if I kget po, kget pods, I've got my pod running. That's my deployment. So I'm gonna jump into that pod using kubectl exec, and I'm just get the pod name, and now I have a shell in the pod. So I'm in my Redfish cluster in a pod in the default namespace, and you can see the pod host name there. So I'm going to run a script. I have a few scripts to show off here. So in the pod, let's get caller identity, right? What identity does the pod have? Okay, it has the pod role. Great, it works, right? But let's see those environment variables that we set. So and a few others. So we set those pod namespace, service account, pod UID ones. But there's a few others that get injected into the pod by AWS for us. That's that container authorization token file and credential full URI. Those are hints to the SDK to say, here's how you get your credentials. You'll talk to this agent on that URL, and here's the token you need to read from disk to pass to the agent. Okay, so we're going to go really quick to, we'll do this S3 demo first. So we saw that policy in S3, right? We saw those different prefixes. So we're going to create some random data, just read from random, write it to a temp file. And we're going to copy that random data into a bucket under /data. That fails, right? We have to use data and our cluster name. So if we do data cluster name, because the cluster name is an environment variable in our pod, and we put it, once we copy it up there, it works. Great, awesome. If we want to list the whole bucket, we can see what's in there. There's our random data we uploaded, some other data under the Bluefish cluster, some logs from other pods that have run. So if we try to copy bash history from one of those other pods into our temp folder, that's going to fail because that's not our pod UID. If we want to upload our bash history to our own pod's UID prefix under the logs path, that's going to work. And then we'll do secret manager really quick. So if we want to list all secrets, we don't have any secrets yet. So remember we said we can create a random password. Anyone can do that. Okay, great. So yeah, we can do that. Great. Now we're going to save one as an environment variable, and then we're going to create a secret. Anyone see what's not going to work here? There's no tags. I tried to create it without tags. It's going to fail. If I go ahead and add tags to this call, so I set -- tags, key equals EKS cluster name, value is the cluster name, that's going to work. So if I want to go ahead and get that secret value, I can do that because I created that secret. It's in my cluster. If I want to untag that, I can't because we had an explicit deny there. Same for delete secret. We can do that because we own the secret. So actually, I want to run that again really quick because I want to recreate that secret and show from the other cluster. Oh, it's already scheduled for deletion. Okay, so in Secret Manager, you have to delete a secret, and sometimes it's eventually consistent, and this is one of those times. Okay, we recreated it. Great. So we're going to drop out of here, and we're going to go back to our blue cluster. So we're in Bluefish, and I've already created the pod. We don't want to revisit all of that. So there's a pod running. So if we exec into that pod, we can see that the same thing that we saw before. pod end, we can see, okay, we have the same role. We have environment variables. It's a bluefish cluster instead of redfish. But if we want to run a different demo, so okay, we can also create a secret. And we set tags. Okay, so that's the bluefish secret. We can list secrets, and we can see all the secrets. We can see bluefish, that's the one we just created. And we can also see the one up there. That was the redfish secret, so that's there. If we want to try to get our secret value for bluefish cluster, we can do that. If we want to try to get it for redfish cluster, that's going to fail. Similarly, logs, we can copy. We can't copy logs that are not for our pod. And then there's the surprise. What's that? Okay, let's see what that is. And it's a fun ASCII art, so EKS, right? It just works. That's great. And so one of what's actually happening, I kind of alluded to this earlier. The SDK in the AWS CLI and then all the AWS SDKs now is going to take that token off disk, call the local metadata service, the pod metadata service, and get credentials. So I've sort of set it out my credentials here, but you can see that's what it's doing to get credentials. So hop back over. So as I alluded to under the kind of what's happening under the covers here. You have your application container. It's reading a service account from disk in the AWS SDK. It's calling this local pod identity agent. That's that add-on that we installed. And that pod identity agent is calling the EKS API with that token to say, this token, I need creds for it. You know all the details of all the associations, what role this needs. Give me back those role creds.
All right, so just to quickly recap, we talked about how you can secure access into the cluster with the upcoming cluster access management feature. Then we just looked at how you can secure access from within the cluster to the outside. You have multiple options, IRSA or EKS Pod Identity. Then next, we look at how you can secure access within the cluster, right? Imagine, just continuing on our theme of walls and forts and castles. Imagine you are living in pre-medieval England, and you are the king. And how do you protect yourself? You need to protect yourself from enemies that are outside the kingdom, and you also need to protect yourself from within. So this is a picture of Dover Castle. If you look at it closely, there are multiple walls encircling the castle. So even if one wall gets compromised, there's another wall protecting the king. So this is really an example of defense in depth. Now, how do you get something similar in EKS? So first, let me quickly talk about network policies. So Kubernetes has this construct called network policies. By default, there is no isolation, network isolation between pods running in a cluster. But let's say you have an application that's microservices, and you want to put in some policies in terms of which pod can communicate with what. Prior to, I would say, August of this year, the way you could enable network policies on an EKS cluster was by installing a third-party plugin. The default port networking plugin that we make available, the VPC CNI, did not have support for it. We've got a few feedback from customers around that. Customers have told us that now the fact that they have to run multiple plugins to get network policy meant that's adding on to the pod startup latencies. Another feedback is around the overhead and management and support and costs. You have multiple plugins, they have to kind of manage that. And the last one is by increasing the surface area, you're kind of introducing new failure modes. So with that, I'm happy to announce that earlier this year in August, we launched native support for network policies in VPC CNI. Micah will walk you through what we did there.
Thanks. Yeah, so this is really exciting. It's a single plugin. So rather than having to install multiple things just to get network policy, you can use the VPC CNI that comes with EKS and get network policy support. This is also integrated with our other features that we have in our CNI, like EC2 security groups for pods. So in addition to Kubernetes network policy, you can also enforce security groups off box. And then it's just really performant. Rather than using like an IP tables-based way to block network access, it's using eBPF. So what is eBPF if you're not familiar with it? eBPF is it's the extended Berkeley packet filter. It's a engine inside the Linux kernel that intercepts syscalls as they get called from user space. And it's commonly used for things like tracing, security, and load balancing. So this is the exact case we're using it for security. It's a way to intercept calls without having to run or compile the kernel or run custom kernel modules. So under the hood, how does this work? So EKS runs a network policy controller for you on our managed control plane. If you create a network policy, this is a Kubernetes resource, our network policy controller sees that, and then in turn creates a network policy endpoint CRD. That's a EKS-specific CRD that takes the rules that are enforced in this network policy, and each node's VPC CNI agent reads from this network policy endpoint to know what to enforce. So the two key components here really are the network policy controller and then the existing agent that's already on the node. So what does an example of this look like? So you might have a network policy like this. This is a Kubernetes network policy. The name is demo app red NS. And what this does is the first part of the spec here says pod selector. So this applies to any pods that have the label app demo. And so for any of those pods that this applies to, this will allow ingress from namespaces where the namespace name is red. So this is basically a pretty simple selector, but just to say I only want to allow traffic in from namespace red. I don't want to allow it in from anywhere else. And again, this can work together with EC2 security groups as called out earlier. So say you have Amazon RDS or Amazon Elasticache in your VPC, and you've got an EKS node group that has your pods. You can use network policy and the EKS CRDs to restrict pod access to VPC resources as well as cluster resources.
Yeah. All right, next let's look at some of the recent security-related announcements. I'm not going to spend a lot of time on these, but if you just Google search with these terms, it will take you to the right what's new post or blog or documentation. The first one is the network load balancer support for EC2 security groups. So the NLB or network load balancers you provision on EKS clusters can now be secured with security groups rules. So you can have rules saying, hey, my application running behind the NLB can only be accessed by certain endpoints IP addresses. The second one is private link support for EKS management APIs. So this gives you a secure private way to access your EKS management APIs from within your VPC. So you're not egressing through the internet or public network. You can directly, through a private network, reach out to the EKS management APIs from your VPC. Third one is some enhancements to Amazon Detective. So the VPC flow logs that you collect from EKS, Amazon Detective now offers a lot more analytics and visualization. The fourth one is the improvement we made to guard duty integration for EKS. So earlier, you could use guard duty to kind of monitor all the traffic to API server. But now we are extending that where you can have a guard duty agent running on your cluster on the worker nodes to now look at the worker node OS level kind of issue. So guard duty can flag OS level issues for you. And finally, we launched this capability where you can sign and verify the container images that are deployed to your EKS cluster. This is enabled by a few different AWS services. So there is AWS Signer, which is a managed signing service. So AWS Signer has made some improvements where you can easily sign an image. You can store the signed images then in a container registry like ECR. And then anytime the image gets deployed to an EKS cluster, you can have an admission controller, gatekeeper, query, or you can write your own admission controller. We have an example in the blog post where you can then verify the images before they are deployed to the cluster itself. Now, if you're interested in learning more about it, please do search for them online, or you can just ask us after the session. So to quickly recap, we looked at three facets of how you can secure a cluster. First is securing access into the cluster. And you have two options. You have the existing config map way of doing things that's going to continue to exist. If you like that, you should continue using that. And then we have the upcoming feature, which is going to be launched soon, called Cluster Access Management, which we think is a more streamlined and better experience for setting up access. Second, we talked about how you can secure access from within the cluster to outside. You have, again, two options there. IRSA is one option that has been around for a couple of years. Now we have another option, EKS Pod Identity, which streamlines the whole experience of how you can grant IAM permissions to your pods. And finally, we talked about network policy and how that is natively integrated with VPC CNI to secure access inside the cluster. We are very excited about these features. Hopefully, we are giving you the bricks to build your own wall.